Hello dear, welcome to this YouTube class. Today we are going to discuss on circular motion. Just to let you know that we have already made one video of circular motion. If you haven't checked it, please do click on the link you see in the iCard so that you can get acquainted with the first class of circular motion, the very introductory class of the circular motion. Here in this class, we would like to see that when the object moves around in a circular motion, we know that it accelerates. If it accelerates, then acceleration acts towards the center of the circle. We would like to see how the acceleration acts towards the center of the circle, how we can prove it with the aid of a diagram. So if we just draw a vector diagram, this will enable us to find out the direction of the acceleration when the object moves around in a circular track. This is what we would like to see here. So we drew a circle when we suppose that the object is moving around in the circular path in this anti-clockwise direction. And we chose 2 points on this circle, A and B respectively, where the object reaches from A to B after time t. As we know that velocity is always acts along the tangential direction, so we have drawn the VA and VB, the velocity of the object at these 2 different points A and B along the tangential direction. The tangential direction that we drew, keeping this thing in mind, that object is moving around in a circular path in this anti-clockwise direction. So now we would like to draw a vector diagram, and I hope you know that head to tail vector diagram, how it is to be drawn. You have to choose one vector as the first vector, and the second vector must start from the head of the first vector. So I drew VA from the head of VB, and the resultant starts from the tail of the first vector to the head of the second vector. So this is going to be the resultant vector, the green line one, and it is resultant, so it is VA plus VB. But will it serve our purpose? Will it give us the direction of the acceleration? Because we know that acceleration is rate of change of velocity. So rate of change of velocity means the difference of velocities. But here by this vector diagram, we got the addition of the velocities. So this is why, look at this now, the diagram I drew, I just changed the direction of VA. So I drew it in the opposite direction, and that's why it is negative VA. The resultant started from the tail of VB to the head of VA, and we are adding them vectorically. VB plus negative of VA is VB minus VA, that is del V, the change in velocity. So here is one thing, that why did we take the VB to be the first vector? Because you know that acceleration is final velocity minus initial velocity. So as the object is moving around in the circular motion, B is the final point, A is the initial point. So that's why I chose VB to be the first vector, VA is the second vector. So here we have seen that this resultant is acting towards the center, which is giving us the difference of the velocities, the change of velocities, del V. And acceleration is, as we know, del V by t, and t is the time that it takes to reach the point B from A. Now the thing is, time is a scalar quantity, it has no direction. So what would be the direction of the acceleration? The direction of acceleration is along the direction of the change in velocity. And we have seen that change in velocity is acting towards the center of the circle. So this is the diagram that we drew, the vector diagram that we drew, and proved that acceleration acts towards the center of the circle. My recommendation to you is, if you have been asked to draw this diagram to prove the direction of acceleration, choose the 2 points A and B very close to each other, not far away, not very close, but moderately close to each other, so that if you draw the vector diagram, you can end up drawing the diagram that resultant acts towards the center of the circle. All right. Now, if we look at this particular point, that acceleration is rate of change of velocity, that is what we know. In the circular motion, the object moves with constant speed. It moves with a constant speed, but not with the constant velocity. Now, if acceleration is rate of change of velocity, that is what all we know, it is correct. So this v and u is same, the magnitude, because speed remains constant. And if the magnitude is same, and if we look at this equation, if we use this equation, we are inevitably going to get zero value. All right. So what is going to be the expression of the acceleration? That is for sure we are not going to use a equals to v minus u by t when the object is in circular motion. It does accelerate. The acceleration is not zero because here velocity changes as the direction changes. So direction changes, velocity changes, that causes the acceleration. Acceleration is always there when the object is in circular track. But this acceleration magnitude cannot be calculated with the help of this just v minus u by t, because on a broad scale we understand that when speed remains constant, v and u, they have the same magnitude. So if I put down the same value here, I'm going to get zero value. So we are having the expression of acceleration is in terms of the radius or in terms of the angular velocity. This is the expression a equals to v squared by r or omega square r or v omega. I'll be proving this equation in the next video. Hope you understood so far what I discussed. If you have any question, please do comment here so that I can get back to you with the answer. Thank you for watching this video. Thanks a lot.